Hello everyone, let's start with the derivative section of the book. After completing this video, you will be able to plot tangent line at any point on the graph. As you can see in the diagram, this is a graph of y equal to x square, and I have plotted 5 tangent line on this graph at x equal to 0, x equal to 1, 2, 3 and 4. Now let's start with understanding what does derivative of a function at a point actually mean. Here we have taken a graph of y equal to x square, and let us assume that we have to find the derivative of the function at x equal to 2. So this derivative will represent the rate of change of y with respect to x at x equal to 2. And how do we calculate this rate of change? We calculate the slope of the line joining x comma y and x plus delta x comma y plus delta y when delta x is tending to 0. I hope you all will be familiar with this concept. I'm just giving a glimpse of what derivative means. So this is the theory part. Now let's come to the coding part of how to plot tangent line on the graph of function y equal to x square. Here I have defined a function f which takes an input a and returns its square. Then I have defined a array x which is a numpy array which ranges from 0 to 5 taking each step of 0.001. Then I have passed this numpy array to function f, which means y is now of similar shape as x containing its squared element. Then I have defined a list named colors containing the string of different letters, and later we will see that we will use this list to give various color to our tangent lines. Now before explaining this function, I hope you all understand this simple concept. To define a line completely, we need two parameters. First its slope and then its y-intercept. If we have these two parameters, then we have the complete information about the line. Suppose we have to find the corresponding y value on the tangent line when x equal to 2. Then the corresponding y value will be 2m plus c. We are doing the same thing through this function. The name of the function is approximate tangent line, and it is taking two parameters x and approximate derivative. Here approximate derivative is the slope of the tangent line, and what it is returning is that it returns the corresponding y value which is mx plus b. Here b is the y-intercept of the tangent line. Now let's try to understand this for loop. In this for loop, I is taking value from 0 to 4, and after completion of each iteration, we will have plotted a tangent line to our graph. As I have previously explained, to plot a tangent line to the graph at x, we need a neighboring point of x which is x plus delta x, and delta x will be tending to 0. And here you can see I have taken delta x equal to 0.0001, which we can assume it to be tending to 0. And x1 will be equal to I. x2 is the neighboring point of x1, so x2 is x1 plus delta x, and y1, y2 is the corresponding squared value of x1 and x2. If we assume I to be 1, then x1, y1 will be 1, 1, and x2, y2 will be 1.001, and y2 will be the square root of x2. Now we have 2 points on our tangent line, which is x1, y1 and x2, y2. If we have 2 points in a line, then we can calculate the slope of the line. And here what I have done, approximate derivative, it is the slope of the tangent line, and it will be equal to y2 minus y1 upon x2 minus x1. We can also calculate the y-intercept of the line, and we can use the formula c equal to y minus mx. Here if we put any point on the tangent in this formula, we will get this y-intercept of the tangent line. So I have put it y2, x2, y2 in the formula. So the y-intercept will be y2 minus slope into x2. Now we have the values of slope and y-intercept of our tangent. So let's try to plot this tangent on our graph. As tangent line can be infinitely long, so we have to declare some starting and end point of our tangent. As you can see in the diagram, when we are plotting tangent at x equal to 0, the tangent started from negative of 0.9 and extended till 0.9. So what we are doing is that suppose we have to plot tangent at x equal to x1. So we start this tangent line 0.9 before x1 and extend it till 0.9 after x1. So this list contains 3 points: 0.9 left to x1, x1 and 0.9 right to x1. Then we are using plt.scatter to plot all those points at which we are drawing our tangent line. And thereafter we are using plt.plot to draw the whole tangent line. Here in this case, plt.plot is taking 3 arguments. The first and second one are list, and the third one is the name of the color in which we want our tangent line to be. Let's try to understand the second argument of plt.plot. Here in the second argument, we are using map function to generate a list. And inside the map function, we are giving it 3 arguments. The first argument is a function, which is approximate tangent line. And the second and third argument of map function are list. And what map function is doing is that it takes out the first element of list 1 and list 2 and pass it to the function approximate tangent line. So overall map function will generate a new list which will be the returned value of approximate tangent line function. And the overall second argument of plt.plot is the corresponding y value on the tangent line. So overall plt.plot is plotting the tangent line with the use of 3 points. So overall plt.plot is joining 3 points to draw our tangent line. After completion of each iteration of the for loop, we will get a diagram like this. In this diagram, you can see that we have 5 tangent lines which are drawn at point x equal to 0, 1, 2, 3 and 4. You can see that in this diagram, we have not plotted the graph y equal to x square, which we can plot using this plt.plot, and finally our graph will look like this. Here in this diagram we have all the tangent lines as well as the graph y equal to x square. So this is the end of the video, and now you can complete the derivative section of the book very easily.